Coming up next, Seven will be back to talk a little bit about how decentralization is the new encryption. This is a very big topic, and it's one I'm really glad we're covering today. We talk about identity, we're talking about privacy, what's next in this logical narrative. Well, Seven, Dr. Stephen Waterhouse has a lot more to add, and he may tell us a little bit more about what was happening with Orchid too. So Seven, I'll let you take it from here.
Hey, everybody. I'm just going to try and figure out actually how to share a screen, which hopefully I can do. Screen sharing works best with 2 monitors. Oops. That's going to be challenging. Oh, I see. Application window. And this is like ETHDenver, so I'm just going to keep it really real. Let's see. I think this works. Is this working? Does that work? Okay, pretty much. All right, so it's kind of a provocative title. We're not trying to say like decentralization is a new kind of encryption. It's kind of like more like in the spirit of how we think about encryption and how the sort of battle for encryption today, end-to-end encryption. What we're trying to say is that there's something new, and it's not that new. It's just new to a lot of people. So let's just try and get into what do we mean by encryption. Most of you, hopefully, given that you're at a hackathon and understand what encryption is, this talk is designed to be given at many different levels. I was just fascinated by the idea of encryption as a child, and it's not a child, but a teenager, and just constantly digging into cryptography books and trying to understand and making my own codes. But we're trying to keep things secret. That's the basic concept. It's obviously a key component of privacy, and it's actually it's such a powerful thing that the basic aspects of cryptography and the mathematics behind cryptography and the code that was developed for cryptography was classified as a munition. It was classified in the same category as nuclear weapons, and was prohibited from being exported from the United States for many years, actually to the point at which a friend of mine started an encryption company for web technology in Germany because of this issue that you couldn't actually export United States crypto. So they went and built the same crypto somewhere else, and were very successful from it. So when we think about encrypted services, it's very interesting to think through the fact that when the web started, there was encryption was not a by default part of it. Initially, it was HTTP only, and the idea of HTTPS, which is, as you see on the kind of top of my screen here, is HTTP plus encryption. It was originally SSL, TLS. It's a technique which is used to encrypt the traffic between my browser and the server. There are many encrypted services today that we think of, and when we throw this concept around of what encryption is, it can get kind of confusing. Nonetheless, despite the confusion, governments are trying to crack down on this general concept of encryption. They look at things and say, we're gonna get rid of encryption because we found that there are some bad people out there, and legitimately there are some bad people out there, doing things, and they're using encryption to do it. So what do they really mean by this, and why are they going after this set of mathematics and this code that does it? Well, WhatsApp is an example here, and WhatsApp is now like under a lot of scrutiny by people. Nothing's really changed. I mean, I'm gonna poo-poo this a little bit, but nothing's really changed in what WhatsApp's doing as far as its protocol is concerned. The new thing that happened with Facebook was that WhatsApp business accounts were allowed to share information with Facebook, but the actual protocol itself hasn't really changed much. But obviously there is this general concern that part of Facebook. Now, what's going on with WhatsApp, which is I use WhatsApp a lot. I also use Signal, and when you're looking at a messaging application, you really want to be thinking through, what am I using here? Like how does this thing really work? And the cool thing about WhatsApp and Signal and similar things to this is the idea that they use end-to-end encryption. And other applications like Facebook Messenger, Telegram, and so on, they don't necessarily do end-to-end encryption, meaning that the messages are getting stored on a server somewhere. You notice when you join a Telegram chat and a group, and you can go back and you can scroll through the messages, it's because the messages are actually stored on the server. You can go back and see these things. So you want to think through these things, kind of what sort of encryption you're using, what is the actual mechanism behind these things. And one of the problems in today's world is that a lot of this stuff is quite opaque or confusing to the user. This kind of concept of privacy is really very fundamental. There's obviously a lot of people fighting for it. We tend to think now that being private is a very important thing for us. It's sort of like we believe it's a right. The idea of privacy as a right is kind of a new idea. When we lived in villages, the idea that you'd be private was just sort of like ridiculous. I mean, like, of course, everyone knew what you were doing. Right? It was kind of just part of life. As we scaled out to cities and larger global communities, we started thinking through like, well, what does it mean to be private? And we started putting these things in Constitution and European Bill of Rights. And now we think of privacy, as, especially on the internet, as something that we really need to protect. Well, how do we get into this concept of decentralization? We think about decentralization a lot. Well, I think about decentralization as one of the most important things about it is the idea of permissionless systems. So I've been working in decentralized systems actually since the early 2000s, and distributed storage, and more like distributed versus decentralized. Decentralized, when it came to Bitcoin, the real concept here of what was permissionless was the permissionless way that you could store money. You didn't have to open a bank account. You still don't. You just create a Bitcoin wallet and put something in it, and you're all good. With Ethereum, you didn't have to get permission to go raise money from the Silicon Valley Boys Club of VCs and angels. You just put something out there on a white paper and money came to you. Sometimes it was a good idea, sometimes it wasn't such a good idea. Now with DeFi, no one has to give you permission to take a loan, you just go do it. And this concept of changing the structure of permission in these systems, we think is very powerful. Now in Orchid, what we're doing is focusing on communications. With Bitcoin, we've been focusing on store value. Filecoin is now interesting because we're focusing on storage. Ethereum obviously is a much larger computing framework and the whole space of smart contract platforms. We can talk about these for days, and we have been talking for days. With Orchid, what we're focusing on is communications. Now, why should we focus on communications as being permissionless? Well, because people want to stop you talking. People want to stop you saying things. They certainly want to stop former presidents from speaking. We see, former President Trump being deplatformed. Good thing, bad thing, we could debate that all day, but it certainly got a lot quieter when he stopped talking. But just this general idea that there's people out there trying to stop you talking. And if you live in China, you're very familiar with this. You're very familiar with the idea that people don't want you to access information, and they don't want you to say things. They don't want you to talk about viruses. There's now like a big campaign inside China trying to stop COVID from being associated with China, like trying to say, actually, this thing came from the United States. So they're kind of rewriting history. I mean, maybe that was the case. Maybe somebody went over to a market in Wuhan and gave some pangolin on COVID, and then it spread from there. But I think it's more likely that it probably came from China. But the doctor who originally discovered COVID and one of the doctors who discovered, tried to warn everybody. He was detained, arrested, probably beaten up, and unfortunately died of COVID quite early on. So we think that the idea of being able to open this network of communication up so that it's much easier to communicate and you're not being surveilled and it's private is very important. So one of the things we have is we have a bunch of apps. We have these apps, and what they allow you to do is build circuits. The circuits are essentially connected to different providers. The providers are VPN, if you like, so like essentially like VPN nodes. They do a little bit more than just a VPN network normally does. And interesting about this is that in a similar spirit to other onion routing technologies that have been seen in the wild before, we're enabling you to construct custom circuits from different nodes in the network, and each node is paid using a cryptocurrency. And the cryptocurrency we're using in this case is the OXT token. OXT is also used to actually stake against these providers, and so the amount of stake that each provider has corresponds to the amount of traffic that provider is going to receive. So one of the things people often say is, well, how do you make this thing scale using Ethereum? Well, we use Ethereum because it's the most decentralized smart contract network, and obviously the tooling around it and the size of this thing makes it very attractive to build things towards it. How do you get this thing to scale? We're all quite familiar, of course, with speed and cost and so on. Well, we have a layer 2 scaling solution that we built. We don't often talk about it as a layer 2 scaling solution, but basically it is. It's we call it probabilistic nanopayments. The concept here is that instead of sending a whole amount of OXT each time you want to do a transaction, each time you're sending a packet of data to another node, and then it's going to be sent on to another node, and so on until it finally gets to its destination. With each of those packets, we associate a certain amount of payment. Now, we could send OXT with that, but then that would need to be transacted and moved and so on. And the speed that we could move the network out would be limited by the speed that we could do that on Ethereum. Problem is, we want to do this at data networking speeds. We want to do this at speeds that you're used to, streaming a movie from HBO and so on. So we want to pay the providers in between all the time. So what we do instead is that we send essentially like the chance of a payment. These nanopayments each represents essentially a kind of like a ticket. Now the ticket, most of the time loses, but occasionally it wins. And when it wins big. It wins a whole pot of money that's associated with effectively the expected value of the payment spread across over time. So kind of get the idea here. This is very efficient, and it means we can scale our speeds to orders of magnitude faster than we can do on any layer 1 that we build on. So whatever layer 1 it is, we can scale it orders of magnitude faster. I think it's very interesting. We're going to be actually writing quite a bit about this soon to kind of compare it to different scaling techniques. We've not only got a whole bunch of crazy tech behind this thing, we've also tried to abstract it so it's easy to use. And one of the things we've done actually is add in-app payments, so you can just pay with a credit card. What happens here is you're not actually paying and getting OXT, you're actually paying and getting a smart contract nanopayment pool, which allows you to start using it immediately. Jumped ahead too fast there. We're on a bunch of platforms: iOS, macOS, Android. We also release Linux. We have a Windows command line, and I hear the community is working on getting the Windows out there fairly quickly. We're connected with a lot of the big wallets, obviously, and we now, I believe, are on all the major exchanges in the world. And kind of just like closing up, I think I've got a few minutes left, maybe some questions at the end. Kind of wrapping this concept up, let's focus on protecting encryption. End-to-end encryption is very important, and we should really, like I was saying in the previous comments, it's not just about building the code. We have to build the societies, and we have to care about this stuff and make sure that it sticks around. It's fragile. The technology is not fragile, but the use of it can be fragile. And in addition, I believe that the combination of strong encryption and decentralization is going to give us something that's not only private, but also resilient. And this is how you can find us. I'm good. If we have any questions, I'm happy to go with it, David.
Well, Seven, actually, the crowd did have some fantastic questions for you. I'm going to ask right now. One of them is,
ask me the hard ones.
Beyond VPNs, what are the good use cases for nanopayments?
That's a good question. So it doesn't work quite so well if you've got something like, I want to pay you, right? I want to pay you something. And you're like, well, yeah, hey, you paid me, but I didn't get it. I was like, oh, well, if we do this payment enough times, eventually you'll actually get what you're looking for. Because it's probabilistic, right? So that doesn't work so well. But if you were providing me with like a video stream, right? And I was like, okay, well, I'm just going to pay you these little nanopayments. The advantage of having this micro mechanism is that I don't have to agree that I'm going to watch it for 10 minutes and then at the end I'm going to pay you. Or I'm going to give you the payment first and then you're going to give me 10 minutes to stream. I can just pay you by like the packet, right? And at any point in time, because you're going to have enough packets over time, you're going to get basically the same value. So we think that that's one interesting application. Just the general concept of providing content, sort of like long-lived services, many-to-many connections. We think there's a bunch of applications. We're in the process of, we've been very focused on this original use case, but we're in the process of developing documentation and kind of getting the community more involved. We actually had a kind of a hackathon project almost ready for this particular ETHDenver session, but I think we're going to do something. We'll be back next year, hopefully in person, to do one, but we'll be doing some specific focused hackathons around Orchid quite soon.
Excellent. And Orchid, of course, started with some of the best known and actually trustworthy VPN services. And a lot of people have been talking about kind of its eventual pathway, one that's been talked about before, and letting more and more people participate. Kind of where do we stand right now with Orchid?
Yeah, so we get this question a lot, is like sort of when staking. Well, when staking, we already do staking. The whole system is built around staking. There's a couple of interesting things here. One is the concept of delegated staking, and that's now ready. And the question is now, like, well, when you've got a system that has this many nodes and the staking is working okay, and the economics are kind of just about okay for the thing, how do you add more people? Well, as you add more people, this is not like sort of regular like proof of stake. You need more traffic. So one of the things we've been really working on a lot recently is making sure that the client is very solid and there's been kind of a number of payment challenges that we've been sort of wrestling with as a result of like gas costs going up, right? You know, all the DeFi degen guys have been like forcing gas prices up, so it's been making life really difficult. Our nano payment scales for speed, but like any layer 2 scaling, you have to buy into it. And unfortunately, each person has to buy in each time. And so the cost of buying in has just been going up and up because the contract is a certain size and gas prices go up. So we've been working on some techniques to fix that. And we believe that once we release that, then we'll get some significant growth in adoption of the client, which will lead to more traffic, which will lead to more demand for providers and then more staking. So it's kind of like a bit of a chicken and egg in building these networks to like really get them to work properly. Excellent.
Well, Seven, thanks so much for giving us not only a history lesson on decentralization in a lot of ways and in encryption, but of course, giving us an update on Orchid as well. Thanks so much for being here.
Thanks. Cheers.